Okay, here's a think, pair, share. So of course, try this one on your own. Come back to this video if you need some help. A government bureau claims that more than 50% of U.S. tax returns were filed electronically last year. A random sample of 150 tax returns for last year contained 86 that were filed electronically. So the question is, test the claim at a 5% significance level by comparing the critical value versus the test statistic and the significance level versus the p-value. Okay, step one. Let's look and see what was given. So Government Bureau claims that more than 50% of US tax returns were filed electronically. So what we're looking at here is a population proportion greater than 0.5. Okay, a random sample of 150. So we've got a sample size of 150. Tax returns last year contained 86 that were filed electronically. So that means the number of successes was 86. So this is different from the previous example where we were given a percentage and we had to calculate this. But now in this one, we were given the number of successes. All right, test the claim at a significance level of 0.05. So if the significance level is 0.05, then that means the confidence level is 0.95. All right. Now, if we were to calculate the proportion from our sample, that would be the number of successes over the sample size, which would be 86 over 150. And that comes out to 0.573 repeating. So in our sample, we had about 57.3% of people filing electronic tax returns. And we're kind of looking to see whether it was significantly greater than 50%. So that's what we're going to be looking for. So if the population proportion was 0.5, what would be the population proportion of failures? Well, it's 1 minus p. And so 1 minus 0.5 is just going to be 0.5. Now these values, these ones here will be used, if you wanted to manually calculate the test statistic yourself. But we're going to use the calculator to help us with that. All right, but I think now we can just go ahead and move on to step two. So step two is to set up our null and alternate hypotheses. So we have our original claim of p greater than 0.50, and I forgot to write it above, so I'm going to make sure I don't forget to write it now. And what is the complement of greater than? It's less than or equal to. And because we've got equal to, that's going to be our null hypothesis, and our alternate hypothesis will be the other one. And because the alternate hypothesis looks like an arrow going to the right, this is going to be a right-tailed distribution. And I also forgot to point out is that because we're dealing with proportions, this is implying that we're going to be using a normal distribution. And we're going to be using normal distribution functions right around that. Okay, so I think we've gotten all that we're going to get from step two. So moving on to step three, this is to calculate our z-test statistic and p-value. And if we were going to do that manually, we'd use this formula. Okay, And, this P prime, P and Q that I calculated earlier, are the P prime, P and Q that you would need down here. All right. But we're going to use our calculators to give us our z-test statistic and our p-value. So here our proportion value that we're using for our hypothesis test is 0.5. We have 86 successes out of a total of 150. And our alternate hypothesis is p greater than 0.5. Okay, so on the numworks, that's going to be 0.5. We have p greater than 0.5. Now let's scroll down. The number of successes we have is 86 out of 150 with a significance level of 0.05. All right, so let's go ahead and plug those into our calculators. Look at this. So we need to use a one proportion z-test. So stat tests, go down to a one proportion z-test. The proportion that we're interested in is 0.5. We had 86 successes out of 150 in our sample size, and we're dealing with p greater than 0.5. So we need that one. Okay, I'll leave those values there for a minute. Now we want to go to the inference app. So I'm just going to hit home, go over to inference, click OK. All right, now I need to back out because I want to kind of go from the beginning to help you out. So after you select inference, we want to go to tests. We're doing a one proportion test, one sample proportion. Our value is 0.5, and our alternate hypothesis is greater than, p is greater than 0.5. Click next. Okay, the number of successes we had was 86, sample size of 150, significance level of 0.05. Okay, so we have a z-test statistic of 1.96 and a p-value of 0.036. So let's come over here to the what did I do? Oh, did I hit quit? Sorry about that. Let's see, I don't know what I did. Let's go back. Okay, everything is still in place. Okay, so let me go down to calculate, hit enter. All right, so we got a z-test statistic of 1.796 and a p-value of 0.036. All right, so let's go ahead and record that. So a z-test statistic of a positive 1.796 and a p-value of 0.036. Okay, and this is going to be a right-tailed distribution. Positive 1.796 and 0.036. Okay, so let's go ahead and scroll down to the next page. And let me go ahead and write those values in. There we go. And step 4 is to set up our distribution, and we'll calculate our z critical value. So I'm giving you plenty of space so that you can draw and annotate everything that you need. Okay, this is right-tailed because that's what our alternate hypothesis told us we're going to have. So we're going to have a positive z crit value. The area in the tail is our significance level of 0.05, confidence level of 0.95. So we're going to reject the null and then fail to reject the null. All right, so to calculate this critical value, we need to use an inverse norm function because we're dealing with a normal distribution. So because I forgot to write these in last time, let me go ahead and do that. Like so. Okay. So let me click home on the numworks. We're going to go to distributions. Okay, normal distribution, but let me back out all the way. Okay, so you can just kind of see me go into it from the beginning. Okay, mean 0 and 1. All right, now I want the area to the right and an area of 0.05, which is positive 1.645. Okay, on the Texas Instruments, clear out of this. We want to go to inverse norm, which is in the distribution function. Okay, so an area of 0.05, mean of 0, standard deviation of 1, and I want the area to the right. And I'll hit paste and go positive 1.645. Okay, so I get a Z critical value of positive 1.645. So positive 1.645. Now let's see where that compares to our test statistic. So our test statistic, let me use a different color, is positive 1.796. That is barely right above. That's going to be somewhere right about there. So that is our Z test statistic, which is 1.796. But that's good enough to firmly put us in the reject the null region. This area adjacent to our test statistic, that is our p-value. And the p-value was 0.036. And as you can see, this p-value is smaller than the significance level. Okay, so the fact that the p-value is smaller is pointing towards rejecting the null. So comparing areas, we're being told to reject the null. Comparing values on the number line, okay, is telling us the same thing. So let's move on to step 5. So because if the p-value is smaller, then you reject the nuller. So we're going to end up rejecting the null hypothesis, and the alternate hypothesis was our original claim. All right, so let me scroll down and see where that's going to fall on our conclusion table. So we're going to reject the null, and the alternate was our original claim. So where those come together is right here on this outcome. So now we just have to write a conclusion with that. So there is sufficient evidence to support the claim that significantly more than, oh, okay, just because I've been consistent. Okay, I'm going to use green. Okay, that significantly more than 50% of U.S. tax returns were filed electronically, and that is with a 95% confidence level. Okay. So, this is another example of the third type of um, hypothesis test that we have in chapter 9. Um, worked it out all the way from beginning to end. Let me know if you have any questions.